And if you read my title, I really don't have to talk because it's so freaking long that I've given my talk in the title. So it's the one on the right, is that correct?
That's right.
Okay. The USGS began a program back in the 90s called the National Water Quality Assessment Program. And in the early 90s, what they did is they did a lot of data collection, a lot of report writing. The second decade, the 2000 decade, they wanted to kind of ramp that up a little bit and do some regional assessments. So they basically divided up the country into these regional areas. And what they wanted to do is take a look on a regional scale what's happening in those regions from both groundwater and surface water standpoints. So I got involved in that because of my interest in nutrients, and also because I drew the shortest straw, but that's okay. So I have a big interest in nutrients and suspended sediment, and that's kind of what most of my career is about, and has been, and I've had the pleasure of working for the USGS now for 22 years in Mississippi. So the area that we're going to talk about today is Major River Basin 5, MRB 5. And yes, it's and we'll go into a little bit more about the study area, but the first thing that we did, phase one, was we took a look at all the long-term data sets that were in each of these regions, and we did a load estimation, and we also did trend analysis of the water quality that's at those sites. So I wrote this report with my colleague Dennis Dimchek out of Louisiana back in 2007, and that summarizes all the trend analysis work that we did for about 115 sites in the blue area there, number 5. And then the next phase was, okay, we had all this data for trend analysis. Now that's at locations where we have sampling information. So what's the next part? The next part is to try to use that and give some estimates for places where we don't have any data. And that is what Sparrow can help us do. So I'm going to talk a little bit, just real briefly. My talk is about the Sparrow model, but I want to talk with you a little bit about that report because it has some implications for this area. Fountain Creek has several sites that have long-term data sets, and we were able to do trend analysis there. And I'm going to focus in on 3 just real quick with this one slide. Fountain Creek below Janetell Road, below Colorado Springs, Fountain Creek near Pinion, Fountain Creek at Pueblo. Our study period for the trend analysis was 93 to 2004, and during that period we saw decreasing trends at all of those sites in several of the nutrient constituents that you see here, ranging anywhere from 3 to 7% per year. So whatever you're doing in Fountain Creek, I saw some posters over here, seems to be working in that particular decade. Woo-hoo. So next, what does Sparrow do? Well, I showed you the map of all those regional studies, and what we're doing with these models is we're using national data sets, and I'll go into that a little bit later. And all of us, from the northeast to the northwest to the south, we've produced these models, and they're all going to be published in a dedicated series of the Journal of American Water Resources Association. This is a little bit behind the second bullet. We've received journal acceptance, so we should expect some publication out of this in June, probably. Waiting on the proofs. So we'll talk a little bit about the study area. I'm not going to go into a lot about the model mechanics itself. I'm not the guy who developed the model. I'm the guy that used it in this area. I'm not that smart, so I couldn't develop the model, but I'm kind of the guy that gives it the sniff test as far as the results. We're going to look at the whole big study area as a whole, and then we'll dive down into Colorado, southeastern Colorado. And then I'm going to show you some examples of how the Sparrow model has been used throughout the country. We're also excited. We did not want these Sparrow models to be models that just sat on a shelf. We wanted the public and local governments to be able to use this model, so we developed a decision support tool, an online tool that you can use and get the results for your area. So a little bit about the study area. It is the South Central United States. It's the lower Mississippi, Arkansas, White Red, and the Texas Gulf basins. Encompasses 11 states. My team is in Mississippi, Louisiana, and Texas. We do a lot of conference calls, a lot of WebEx presentations to work together. I want to show you this slide to give you a little hint about what we expect the model results to show. As you can see, you could probably draw a line right down the middle, north to south of the study area, and to the right In the eastern part, you see the lusher areas of where in the Mississippi Alluvial Valley, where a lot of row crop production is, and also a lot of forested areas. And then to the left is our more arid areas, and where a lot more as you prairie areas, that as someone else said. And another one, if you drew a line right down the middle of the study area in rainfall, you all get about 20 to 30 inches per year of rain. No? Wishful thinking? Centimeters. Well, we in the South get about 50 to 60 inches of rain, so that kind of tells you a little bit about our study area and how the modeling is basically study area limited. So what is Sparrow? I'm not going to IBCC, I heard that. What the hell is IB? I'm going to tell you what Sparrow says. And we have people in the USGS that their living is to develop acronyms, I think. That's my opinion. But Sparrow stands for Spatially Referenced Regression on Watershed Attributes. Ms. Nancy showed some results from that 97 model that Dick Smith and others wrote for this area. It is a regression-based model, which means that it's calibrated and adjusted to monitored loads. It's a hybrid mechanistic, so it's not just playing with the numbers. It's also, it has terms that will take sources of nutrients and take them and deliver them to a stream, and then from there degrade them in the stream. So, but it's a static model. It is not a trend model, so it's not going to show you what I showed you earlier. It is centered on a specific target year, and in this case, the year is 2002. So we made a 5-year improvement over the other ones, but we're still about a decade behind. But and one of the reasons I'll show later about how the model was assembled and why that 2002 is the way it is. So basically, we take sources like atmospheric deposition, livestock manure, fertilizer, point sources, whatever, and we take those sources that hit the landscape, and then the model transports those sources to the stream, degrades them in the stream, and then estimates loads in the stream, and then it calibrates itself against where we actually have monitoring data. So that's about all I'm going to show you on that. Oops. So part of it is we need to have these load estimates like we did with the trend study. So this particular phase of work, we did not, I hit the wrong thing. How do I get it back?
The bottom button.
Okay. I didn't want to rely on just the national databases of the USGS and EPA. We weren't sure how some states populated the STORAT database of EPA, so we went on out to the states themselves and pulled and got data dumps from them, some selected ones. We started with 22,000 sites that had at least one nutrient sample, and that's what it looks like. And then from there, we culled it down, and from a data screening standpoint, we applied some criteria of what we wanted, things like 25 samples. We wanted data sets that ended near our target year of 2002. We didn't want sites that just had summer samples. We wanted sites that had samples all throughout the year, and other things. I'm going to go quickly through that. So that culled down to 1,800 sites roughly. And that's just where water quality data exists. So in order to calculate loads, you need flow as well, flow information. So we went from 1,800 down to 344 for our nitrogen model, 442 for our phosphorus model. Being the used car salesman that I am, this is a slide that I like to put up there because you've heard today, you're about to make a lot of socioeconomic decisions on nutrient criteria using very little data. Pardon me, I've had a cold and have this little tickle in my throat, and I don't want to start hacking. But fortunately for Colorado, you got a little bit better representation up here. So what are these sources that I'm talking about? So we put into the model point sources. The national model that Ms. Nancy showed earlier, they used land use, urban area land use data for a surrogate for point sources. So instead, for this model and these updated regional models, we actually went to the EPA database and pulled that information out. And that's for point sources. And then we also wanted to have some information about non-point sources in urban areas. So we did pull the land use, the urban areas from the 2001 NLCD. Atmospheric deposition. This is a pretty big deal here. Pretty big deal in our study area, excuse me. And we use that information from the USGS National Trends Network. Here's fertilizer data. This comes from the USDA National Agricultural Statistics. I want to pause just a second, and when I get in front of local groups like I am today, a lot of people are wondering, well, why didn't you use our data set? Why didn't you want to use this? And for our studies, we wanted to use national data sets so that when the models were developed, we could compare the results from one region of the country to the other. That's the purpose of this NAQA project. So these data are available annually, and then we get into livestock manure. And one of the reasons why we chose 2002 is for data sets like this, they're only available every 5 years from the NASS in this national data set. And this particular one was available in 02 and 07, and when we first started this, the 07 data were not released, so that's why we chose 2002. Because it's such a big deal, and here's pasture data. So let's go ahead and get into the results. This is an update from the model that you saw earlier. Here's the total nitrogen yield results. Yield is, and we developed two models, total nitrogen model and a total phosphorus model. And the yield is load divided by drainage area. So for every one of the rivers and streams that are in the study area, they are digitized to use, very similar to how the states do their 305B reports and their 303D list. They segmentize all of the streams in your state. And so we did the same thing here, and then all the stream segments have their own particular catchment, sub-watershed. And so what we did on the left side here is how much nutrient load is generated within that particular sub-watershed. And then for these models, my target area for the model is the Gulf of Mexico. So how much of it that's generated makes it to the Gulf, and the figure on the right shows you that. So if you could see the patterns there, like I said earlier, from land use and from rainfall, you see that most of the higher loads and higher yields come from the eastern part of the study area in the lower Mississippi River Basin. That's kind of expected. And we can also map all the sources. And in the nitrogen model, we see the blue is atmospheric deposition. So it contributed around 40% of the total load from this area. See some other pockets of yellow, that's fertilizer and ag areas, and the urban areas there too. So here's the total phosphorus yield results for the study area. What's delivered to local streams, and then what makes it to the Gulf. You can't really see the scale, but phosphorus loadings are about 1/6 of the nitrogen loadings on average. And here are the primary sources, a little bit more of an ag signature with manure and fertilizer there. So what's going on in Colorado? I had to change the scale because compared to the rest of the country, you generate very little compared to the rest of the study area. Why did we put these together? You've heard some mention, the other area that I've been involved with since the mid-90s is BMP effectiveness evaluation studies. And so BMPs are a big deal to me, and how well they work, and do they work or do they not work. And so what the Sparrow model does that I really like, and its best use, is targeting areas where you can go and focus those mitigation efforts. So the darker the color, the bigger the contributor, basically. So what we did is we refocused the target from the Gulf of Mexico to your border with Kansas. Excuse me. And so if I was a manager, I would probably focus on the darker blue areas in the right graph, in the right figure for mitigation. And here are the yield maps for phosphorus. Okay, I hope I make it. Oh, that'd be great, thank you. Sorry. So, and then we have the primary sources. So in nitrogen, it's point sources and atmospheric deposition a lot. And then a little bit more of an ag area, signature and phosphorus. The other thing that we can do is we can tell you how much was applied based on those maps, and how much is delivered to the local streams, and then how much of it is delivered to Kansas. So how have these models been used in other areas? This is a model that was developed for the Southeast. Its results are already published by Ann Hoos. For a particular watershed in Tennessee, the Beaver Creek, Clinch River watershed, this is just a comparison to other models. One of the neat things they did for another watershed, the Elk River Basin, is, oh, thank you, because that Coke is not doing well. Apologize, y'all. The blue triangles there are the original monitoring locations. Using the Sparrow results, we saw an area in darker green there that I guess they didn't really consider before in monitoring, and they decided to upgrade their monitoring so we could help with monitoring approaches. The dreaded Florida nutrient criteria mess that's going on right now that many of you are aware of, we were involved in that. When I use Sparrow for nutrient criteria development, it can certainly be used as one line of evidence in a multiple line of evidence approach for the state. I don't know that I would use it solely. But the other thing that we can do is we can take the results and do a statistical analysis of the results, exceedance probability type work. And if you set some target criteria, we can use the results and say this particular stream segment has a high probability exceeding that particular criteria target. That's one thing we can do. I'm gonna move on. Apologize. One thing that we developed is a decision support tool, and that's coming out with the y'all. Goodness gracious, it's hot up here. Pardon me. Each of the models will have a decision support tool where you can go online. This is my model. Pick it. Go and find a particular watershed or a stream segment of interest. Hone in on it, and then it'll show you the results. Also, it'll capture all the watersheds above a point for you, and if you want to go in and say, I want to reduce all the inputs by 40%, what's the downstream result of all that? So it'll do a lot of management and mitigation scenarios for you. And then finally, if you want any more information about the Sparrow modeling and the regional models, there is a fact sheet online that you can go and get. And I'm gonna stop.